Hi children, how are you? So you are, I hope you are shaping well under my guidance. Okay, now let us start. So here today we will learn solving sums problems. So I planned one thing. First of all, we will discuss in few sums, then algebraic method, and then graphical method, and then word problem. So it will be very much convenient for you to understand everything clearly. So let us start this one, exercise 3.2. So you may have one question. So why, sir, you are starting from exercise 3.2, not from 3.1? Because exercise 3.1 has a word problem, and I have planned to discuss word problem at a time. So everything will be covered conveniently. Now, this is my plan. Now, so I have copied this sum before starting the lecture because to save the time. I will explain you here how we are proceeding the sum. Okay, so let us start. Now, I hope you are agree with my proposal or my planning. Now, so your exercise 3.2, sum number 2, it is a very important sum, and few sums are based on this formula in exercise 3.5. So once we discuss this, you can solve it easily, and one sum comes in exam based on this. So on comparing the ratio of this A1 upon A2, B1 upon B2 and C1 upon C2, find out whether the lines representing the following pairs of linear equations intersect at a point, are parallel or coincident. So this is the question. Now, for this we have this one. I have written here already. So if A1 upon A2 and is not equal to B1 upon B2, then our line will be intersecting. Means we have unique solution and it is consistent. Now, if A1 upon A2 is equal to B1 upon B2 equal to C1 upon C2, then it is a coincident line. Means it will appear that we have two equations, but basically it is representing one equation. So we may call it that lines are overlapping. This is, but in fact they will represent the same line, same equation. Now, so it has line is coincident and it has many solutions. Now here condition number 3, when A1 upon A2 is equal to B1 upon B2 and is not equal to C1 upon C2, then it is parallel line. Both lines will be parallel. If parallel, so there will be no solution. So this is the condition. Now, on the basis of this, we will solve this equation. So this is sum number 1. Sum number 1, we have taken this. You know it very well that A1, B1, C1 are A1, B1 are the coefficient of x and y, and C1 is the constant term in first equation. A2, B2, C2, A2, B2 are the coefficient of x and y in second equation, and C2 is the constant. So we are taking here, this is A1. So A1 upon A2 A1 upon A2 is equal to 5:7. And now this B1 upon B2 is minus 4 upon 6. So it is minus 2 upon 3. So you are observing that A1 upon A2 is not equal to B1 upon B2. So lines are intersecting and has a unique solution. So it is consistent. Sometimes it is set constant, whether the lines are consistent or not. So you will reply like this, and this is our answer. Now, Second part is a1 upon a2. This is 9 upon 18, which is 1 upon 2. 3 b1 upon b2 is 3 upon 6, so it is 1 upon 2. And c1 upon c2 is 12 upon 24, it is 1 upon 2. So all the ratios a1 upon a2, b1 upon b2 and c1 upon c2 are equal. So lines are coincident and have infinitely many solutions. So this is the condition. It has infinite number of solutions, means many points are there which will lie on the straight line. So those points will be the solution of the given equation. Now third condition, third sum is 6 upon a1 upon a2 is 6 upon 2, b1 upon b2 is minus 3 upon minus 1, which is 3 by 1, 3 by 1, and c1 upon c2 is 10 by 9. So what do we observe? So a1 upon a2 and equal to b1 upon b2 is not equal to c1 upon c2. So lines will be parallel. If lines will be parallel, so it has no solution. I hope you got it. Okay. Now let us discuss the second sum. Now this is the sixth sum. I copied it. Now, so what is sixth sum? Given that linear equation 2x plus 3y minus 8 is equal to 0, and write another linear equation in two variables such that the geometrical representation of the pair of so form is intersecting, parallel or coincident. So this is the condition, you know, and solution is C. How will you proceed? So intersecting so this is our given equation, 2x plus 3y minus 8 is equal to 0. Now, so it is first is intersecting. For intersecting, you are knowing that a1 upon a2 is not equal to b1 upon b2. So here a1 upon a2 should not be equal to b1 upon b2. You know it. So a1 is given, it is 2. So let us take 3. b1 a2 a2. So let us take 3. So this equal to, suppose this is 3 and this should not be equal to. So take it 3 by 4. It is 4. So you can take 4, you can take 5, you can take 7, anything. So this should not be equal. So therefore, so our equation will be, therefore equation is, this is 3 and 4. So you will write 3x plus 4y minus 8 is equal to 0. So this is our answer. Understood? So now, so here parallel lines. So for parallel lines, you know that C1 upon C2 should not be equal to A1 upon A2 equal to B1 upon B. It should not be equal. So let us take. So this is our equation. So 2x plus 3y minus 8 is equal to 0. So A1 upon A2, since A1 upon A2 is equal to B1 upon B2 and this not equal to C1 upon C2. This is the condition. So A1 is 2. So let us take 2 upon 4. This is equal to 3. So let double of it is 1 is to 2. So double of this 3 is to 6 and it is not equal to minus 8. So you can take 8 upon 9, 8 upon 10, 8 upon 12, whatever you wish. This ratio, so I am taking 10. So this ratio should not be equal to ratio of this. So this is representing 1 upon 2, 2 upon 4 is 1 upon 2, 3 upon 6 is 1 upon 2, and this 8 upon 10 is not equal to 1 upon 2. So this we have chosen 4 is the coefficient of x in the new equation, 6 will be the coefficient of y and 10 will be the constant. Therefore required required equation. So you can write 4x plus 6y, and this is 10. So you can write it plus 10 is equal to 0. So this is our equation. I think you got it. Now, for this condition, constant means what? See, this is the condition, constant. A1 upon A2 should be equal to B1 upon B2 should be equal to C1 upon C2. So let us see. So this is our equation. So 2x plus 3y minus 8 is equal to 0. So minus this. So A1 upon, since A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Therefore, so 2 is given. So we have taken here 4. So take it 4 is equal to, I plan that ratio should be 1 upon 2. So accordingly, I will choose this one, B2 and C2. Suppose I plan, no, I will take the ratio 1:3. So accordingly, you will do this. If you choose that ratio should be 1 upon 3, so you can write here 6. Understood my point? So now this is 3 upon 6, and this is equal to, it is minus 8. So minus 8 upon minus 60. So 1 upon 2, 1 upon 2, 1 upon 2. Is it clear? So therefore required equation is 4x plus 6y minus 60 is equal to 0. So this is the answer. This is the answer. And this sum is also very important. So we are framing here a very important. Okay, so note it down. Okay, I hope you got this one. Now I copied the sum. This exercise 3.3. The previous thing we have discussed. So you can solve those type of question in exercise 3.3 it is given, and 3.5 also you will get similar sum. You can answer it. I know it very well. Now algebraic in exercise 3.3 algebraic way we will learn how to solve. So I will give you different types of sum we will discuss here. So now this type of sum, I have not considered the simple sum which I showed you in introduction, the way of doing. Now, so here if there would be fraction, and in fraction denominator there is number, numerals. So how will you proceed? So for making this fraction in whole number, if we will convert, so what will you do? So you can write this 6 upon 1. This is equation number 1 and this is equation number 2. So let us remove the fraction. So what will you do? You will take the LCM of all the denominators. So LCM of 3, 2 and 1 is 6. And now you will multiply by 6 in both sides. So you will write here multiplying by 6 in both sides. So 6 into s by 3 plus 6 into p by 2. This is 6 into 6 by 1. So this will cancel, this will cancel. So and this is 36. So 2s plus 3t is equal to 36. So this is equation 3. So now here it is same. No problem, there is no fraction. So we don't have any problem. Now we will consider equation 1 and 3. And here they have told so what will we do? So I am doing here by by elimination method. Okay, so coefficient of t is -1 and coefficient of t is here 3 and they have opposite sign. So it is easy to consider this, eliminate t. So here we will multiply by 3. So you can write s minus t is equal to 3 and we multiply this. Okay, so it will be 3s minus 3t is equal to 9. So this is our equation 4. Now we will add equation 4 and 3. So adding equation 4 and 3 so it is 3s minus 3t is equal to 9. This is 2s plus 3t is equal to 36. So if we add, so this will cancel. This is 5x is equal to 45. So s is equal to 45 by 5, so it is 9. So s is equal to 9. So this is our one answer. We got the value of s. Now we will substitute this. Which one is easier? So it is easier to substitute it. Equation number 1. So putting the value of s is equal to 9 in equation 1. So this is 9 minus t is equal to 3. So if you take this t, it is 9 minus 3 is equal to, we are taking this to this side. So it is 6. So t is equal to 6. So you will write like this. So we got answer. So this is our answer. S is equal to 9 and t is equal to 6. So I hope it is clear to you. Now I am taking another example. So I will give only hint. You will do it. So only I will give you hint, because in this type of sum many students have problem. So I am taking 0. This is actually sum number 4. 1 part 4. 0.2x plus 0.3y is equal to 1.3. So this is equation number 1, and 0.4x plus 0.5y is equal to 2.3. So this is equation number 2. These two equations are given to you and they are in decimal. So many students scared of this type of sum because decimal is there. Simple funda is there. So you will remove, you will change, convert this decimal to whole number. So how will we convert? So think, after decimal there is one digit, here also one digit, here also one digit. So everywhere you are getting one digit after decimal. Suppose if anywhere, if 2 digits are there, so maximum number of digit after decimal, if it is 2, so you will multiply by 100. And since here only one digit is there after decimal, so we will multiply the equation 1 and 2 both by 10. So what will happen? So we are multiplying this equation plus 0.3y equal to 1.3. Equation 1 we multiplied by multiplied by 10 in both sides. So you will get, this is 2x plus 3y is equal to 30. So this is equation 3, and similarly this 10 into 0.4x plus 0.5y is equal to 2.3. So here we are multiplying by multiplying by 10 in both sides. In both sides. So it will be 4x plus 5y is equal to 23. So this is equation 4. So you will solve your sum by taking equation 3 and 4 by elimination method. So I think you can do it yourself. So now let us proceed ahead. Now this is equation sum number 2 of exercise 3.3. This is also very important sum. Now, so what is the question? So solve 2x plus 3y is equal to 11 and 2x minus 4y is equal to minus 24, and hence find the value of m for which y is equal to mx plus 3. So first of all we will solve the equation and then we have to find the value of this m. So let us solve first. So now this is equation 2x plus 3y is equal to 11. This is equation number 1, and this is 2x minus 4y is equal to minus 24. This is equation number 2. So one thing I am reminding you again. So suppose if in your exam, if some specific method is not given, so you will do by any method. Understood? Okay, so let us solve. So here equation 2x is equal to 11 minus 3y, this is equation 3, and this is 2x is equal to 4y minus 24. So this is equation number 4. So if some specific method is not given in question paper, you can solve it by any way which is convenient, which is easy for you to do. But if some specific method is given, you will have to do by that method only. So now, so